All right, this question says, find the open intervals on which the function is increasing or decreasing. And our function is g of x equals e to the negative x plus e to the 3x. So to find the intervals of increasing and decreasing, we need to find the critical numbers first. So I'll calculate the derivative. The derivative of e to the x is e to the x, but because our exponent is negative x, we need to use the chain rule. So it's e to the negative x. The derivative of negative x is negative 1. We'll do the same thing on the derivative of e to the 3x. That's e to the 3x times the derivative of 3x, which is 3. And we'll do a little bit of simplifying. So I have negative e to the negative x plus 3e to the 3x. And that's 3e to the 3x minus e to the negative x. So I'm going to rewrite this as 3e to the 3x minus 1 over e to the x. And I'd like to write this as a single fraction. So that would be, I would multiply by e to the x over e to the x. That would give me 3e to the 3x plus 1 over e to the x minus 1 over e to the x. And that's 3e to the 3x plus 1 minus 1 over e to the x. I want to think about when this derivative is equal to 0 and undefined. So just want to give a little bit more detail here. Oh, I'm sorry. So I think I made a mistake right here. So let's think about what that is. If I multiply by e to the x over e to the x, when you multiply with the same base, you add the exponents together. So I should have added these exponents together to get e to the 4x. And so that makes this e to the 4x. So I want to think about when this derivative is equal to 0 or undefined. So equal to 0 would be when the numerator is equal to 0. So that's 3e to the 4x minus 1 equals 0. I'd add 1 to both sides. That's 3e to the 4x equals 1. Divide by 3, that's e to the 4x equals 1/3. And this is an exponential equation. One of the methods for solving exponential equations is to take the natural log of both sides. Natural log and e are inverse operations and they cancel each other out. So you'd be left with 4x. And I would divide by 4. So I have x equals natural log 1/3 over 4 as a critical number. So then you would want to think about where this is undefined, and that would be where the denominator equals 0. And this exponential function never equals 0. If we think about the graph, it has a horizontal asymptote along the x-axis at y equals 0. And so this piece of the graph approaches that y value of 0 but never reaches it. So there are no places where the denominator equals 0, so we don't get any critical numbers from there. So once you get the critical number, you want to put that critical number on the number line. And then you want to pick test points around that. So I'm going to use my calculator to get a decimal approximation for what that is so I can choose my test values. Okay, so I'm getting a decimal approximation for that critical number. Natural log of 1/3 over 4 is negative 0.27. I'm just going to write that down here. Negative 0.27. So I could pick -1 and +1 as my test points. And you want to substitute those into the derivative to see whether they come out positive or negative. So I'm doing my test points of -1 and +1 and substituting them into g prime of x. So that would be 3e to the 4x. Let me substitute my value in there. 3e to the 4 times -1 minus 1 over e to the -1. Let me use my calculator to get the sign there. And type the derivative into my y equals menu. I need parentheses around the numerator. And I'll go to the graph and choose -1. Sorry, I need to do that in the graph. Second calc value, -1 gives me a negative. And a +1 gives me a positive. So that means that our function is decreasing to the left of our critical number and increasing to the right of our critical number. So we are increasing from natural log of 1/3 over 4 to infinity and decreasing from -∞ natural log of 1/3 over 4.